Hello, and welcome to the podcast. Today, we're digging into a topic that's creating a huge buzz: regenerative agriculture. It sounds amazing, right? Healing our soils, tackling climate change by drawing carbon from the atmosphere and storing it in the earth. It's a powerful vision. But, like many big ideas, it comes with its own set of complexities, particularly involving a vital element for life: nitrogen. This is the soil carbon paradox. At its heart, regenerative agriculture uses practices like no-till farming, cover crops, and diverse crop rotations. The goal is to boost soil organic matter, which is super rich in carbon. Healthy, microbe-filled soils become like sponges, soaking up atmospheric carbon dioxide. This is fantastic for the climate and makes farms more resilient, as carbon-rich soils hold water better and are more fertile. But here's where things get tricky. To store carbon stably in the soil, it needs to become part of microbial life and then stable organic matter. This whole process needs nitrogen, about 1 ton of nitrogen for every 12 tons of carbon locked away, plus what crops need to grow. Many regenerative methods aim to ditch synthetic nitrogen fertilizers because they have a big greenhouse gas footprint. Commendable, yes. But if there isn't enough nitrogen available, the soil's ability to store lots of carbon can be limited. Plant growth itself, the engine pulling carbon from the air, desperately needs nitrogen too. A 2025 Cornell University study highlighted this. Using computer models, they found that many regenerative practices aiming for soil carbon might actually reduce crop yields in some cases. It suggests that improving soil health can either benefit greenhouse gas mitigation or crop yields, but rarely both at the same time globally. For example, grass cover crops with no tilling were best for limiting greenhouse gases, but worst for crop yields in their model. Another 2025 study showed that while less stable carbon increased under regenerative management over 7 years, more stable carbon didn't change much in that time. However, stable soil clumps helped by these practices can protect this less stable carbon. So how do we solve this puzzle? It's about smart, integrated approaches. First, smarter nitrogen management. This isn't about abandoning nitrogen, but using it more efficiently. Think legume cover crops that make their own nitrogen, better use of manure and compost, and precision tech to apply nutrients only where needed. Some companies are even developing sensors for this, cutting down harmful nitrous oxide emissions without hurting yields. Second, focusing on nutrient cycling. Healthy soil microbes make more nutrients, including nitrogen, available from organic matter. Third, diversified cropping systems. Different crops, especially deep-rooted ones and perennials, can boost carbon at various soil depths and improve nutrient use. Think agroforestry, integrating trees with crops or livestock. Fourth, understanding local context. What works in one place might not work in another. Tailored plans are key. And fifth, a long-term perspective. The full benefits of regenerative agriculture, like stable carbon and good yields with fewer inputs, take time to show. Now, some critics argue that the climate benefits of soil carbon might be overstated, or that some practices like no-till could lead to other issues. But the drive to improve soil health remains fundamental to sustainable farming. The soil carbon paradox isn't a dead end, it's a call for more research and innovation. By understanding the delicate dance between carbon and nitrogen, we can refine these systems. The global regenerative agriculture market is booming, reflecting strong belief in its potential. The focus is on truly building resilient ecosystems from the ground up. It's a journey of learning and adaptation, but one aimed squarely at a more sustainable and resilient agricultural future. Thanks for tuning in.